All right, this is question 11 of the review, and it's returning to a question about escape velocity. For escape velocity, what we need to realize is that the total energy has to stay the same. And so an object has kinetic energy at the beginning, it's moving, and by the time it reaches a great distance, or we'll call it infinity, the kinetic energy has now become potential energy. The question is, do you have enough kinetic energy to reach infinity? If you don't, then you haven't escaped. And so the two formulas set to each other, mv squared over 2, it must equal gmm over r. So the potential energy must equal the kinetic energy. Solving this, we get V is equal to the square root of g m over r, where m is the mass of the planet or moon or sun, r is the radius. So we just use the numbers given, mass is given, radius is given in the chart here. And so for the sun, run the numbers, you'll get 6.2 times 10 to the 5 meters per second. For the moon, you will get 2.4 times 10 to the 3 meters per second. And for Mars, you will get 5 times 10 to the 3 meters per second. Right? In question number 12, it wants to know, in traveling to other planets, you have to consider not only the Earth, but also the Sun. Would it be easier to travel to Venus or to Mars? A quick little picture shows us that if this is the Sun, if this is Mercury, Venus, Earth, and Mars, like that. And we want to travel in one direction or the other. It says, would it be easier to travel to Venus or to Mars? Well, if we go from Earth to Venus, we have the gravitational pull of the Sun to assist us. If we go to Mars, we have to work against the gravitational acceleration of the Sun. And so the simple answer is it's easier to go to Venus because you can go with the Sun. It's a little more complicated than that in reality, but for the purpose of the calculation, that's as simple as it gets.